Last lesson we looked at Prim's algorithm for spanning trees, and this lesson we're going to look at Kruskal's algorithm. So this is another way. So to use Kruskal's algorithm, we sort the edges in increasing order of weight. So that's the number on the edge. We make a diagram of the network with all vertices but not edges. We choose the edge with the smallest weight, then choose the next edge, and continue until all the edges are there without any cycles until all the vertices are connected. So we have the exact same diagram as before, the exact same network. So the first thing we're going to do is we're going to write down all of the edges in order from smallest to largest of their weight. So if we look at this network here, our smallest edge is 3. So that would be BF is 3. Then I look, okay, well, there's no more 3s, I'm going to 4. So we have FG, which is 4. I then have AC, which is 5. And I also have CD. It doesn't matter the order in which you put those two. Okay, if you have some of the same order, it doesn't matter there. Then we go to DF, which is 6. EG, 7. AB is 8. EF is 8. BD is 9. DE is 10. We have BC, which is 11, and CE, which is 13. Okay, so that's our first step, sorting the edges in increasing order. We then need to make a diagram of the network with all of the vertices. So like what we did in one of our earlier lessons, we're just going to draw in the network with the vertices. Oops, let's see. D in the middle. Okay, rough diagram, doesn't have to be perfect. Then it says choose the edge with the smallest weight. So we're going from the smallest weight, which is B to F. So I'm going to draw that in there. Okay, so we've done that one. Then we move to the next one. We have F to G, which is 4. So 3, 4. We have A to C. Now it doesn't matter that these don't join in with anything. We have C to D, which is also 5, so we'll use those two. We then have D to F, which is 6. We have E to G, which is 7. Now we have A to B. Okay, if I were to draw A to B, I'm going to start making a cycle here because that is going to join together, and we don't want that. We don't need anything connected around because that would then join all of this together. If I look at E to F, again, that's going to make a cycle. B to D is a cycle. D to E would create a cycle. B to C is going to create a cycle. And C to E would create a cycle. So you can see there, once you start filling it in, we get that spanning tree. We don't have a network or a diagram, it's the tree. So nothing is all connected making cycles. So that's what Kruskal's algorithm is putting it into order and then filling it in from there. So long as all the vertices are connected to something and there's no cycles, that's where we get that minimum spanning tree for Kruskal's algorithm.